There we go. Okay, awesome. So yeah, welcome everybody. We're just going to start with a presentation, just kind of to highlight the entirety of the project, the Polar Federated search, where it stems from and everything. So apologies in advance to those who've seen this presentation multiple times before. It might be a little repetitive, but since we want to have it recorded and up online, it's good to just kind of have it all in one spot. So I won't take up too much time doing so, but it's always good to have some sort of context, right? So let me just get that up. Morning, Adrian. Okay. Okay. So today's workshop is hosted by me, Chantel, in case we haven't officially met before, and Melinda Minch, who is our web developer and our MVP behind the actual development of the Polar Federated search. And today we are going to be going through the actual markup of the POLDER schema.org implementation and the Polar Federated search, to how to get any interested repositories integrated into and indexed into the Polar Federated search. So the project Federated search stemmed from the POLDER community because there of identified overarching challenges such as capacity issues, such as funding, trained personnel, and maintenance uncertainty, lack of standardization in between standardized vocabulary, standardized metadata schemas, lack of best practices. And the main problem for researchers and stakeholders is locating domain-specific repositories. So as we all know, there are polar-specific, Arctic-specific, Antarctic-specific repositories out there, but then there's Arctic and Antarctic data also hosted in more of the generalist repositories, such as like a library or institutional repository. And instead of trying to go through and search, I believe we have 103 repositories or data centers participating in the POLDER space. Instead of going to 103 different spaces, you can kind of go to one user interface and search various repositories through that, trying to save a lot of time and resources. So the goals for today's workshop is the quick overview of the history of POLDER and the Polar Federated search, again, like I said, where it comes from. I will be providing a list of resources for schema.org markup and the various levels that can be implemented, and I will kind of touch on that in a little bit. And then, we'll have Melinda get down to the nitty gritty with the actual implementation of the resource or the metadata that you guys brought along, and actually have that one-on-one implementation help of the POLDER best practices. So POLDER in general, I'm sure we all know, but has been working on best practices document. So this is the actual how to mark up the schema.org in a metadata landing page, and as well as a federated search. And that's what's all bringing us here together today. So the federated search is this one user interface that I mentioned before that can be searching across the various repositories. So we are using schema.org, which is a vocabulary or ontology that was created by the 5 main search pages. So like your Google, your Yahoo, your Yandex, and whatnot. One of the main motivations for actually using schema.org is that Google has created a Google dataset search. So it's supposed to be doing what the Google Scholar does for publications, but in the dataset space. And they've actually created a new development where now dataset searches come up in the main web search instead of having its own web page that you have to go to specifically. It actually comes up in the main search if you're searching for datasets, which is great. So by implementing the schema.org, your repository datasets can show up in Google's dataset search, making discoverability a little bit easier too. So an example of the schema.org in use is, this is kind of more on the technical side, but you have your schema.org tags implemented alongside your current metadata standards and terms. So it's not like you're having to adhere to a new metadata schema or implement something like that. It's supposed to be a lightweight implementation. And our work here at the ITO stemmed from first with the Research Data Alliance, Research Metadata Schema. So this is kind of more the basic level of implementation at just the generalist metadata schema. So you're like your ISO 19 and 115s, your DCATs. I'm blanking on the other ones, but there's, as we know, there's a whole bunch out there. So the Research Metadata Schemas Working Group has crosswalked 15 of the metadata standards available. In between, so it's crosswalking your metadata terms to the schema.org terms. They've created also guidelines for publishing structured metadata. So again, at the basic level of schema.org implementation at just the metadata level. So they did this by a spreadsheet, and it's more user friendly instead of machine readable at this point, but at least individual can kind of go and see the mappings one-to-one, and then across the board for the other records as well. And with that spreadsheet, the ITO came in and tried to take it one step further and use a more user-friendly crosswalk visualization webpage that is still up and running today and has updated crosswalks and mappings. But it includes a filter table, a search table. So if anybody's confused on like, oh, what does DataCite use for their mapping of the schema.org property description, and it's mapped directly one-to-one to just the DataCite term. We also have a Sankey, so it kind of branches out more into seeing which terms are mapped and the more common terms to the various metadata standards, and then a gap analysis highlighting what terms are actually missing from the mappings, because it's not as easy as one-to-one. It takes a lot more human interaction, human kind of knowledge to try and map them. So there are some gaps in some of the term mappings. And from there, the Science on Schema cluster at ESIP has taken the schema.org dataset vocabulary and tailored it to the earth science community. So they took the terms that they found were most relevant to earth science community and actually created a guidance document for how to actually implement the schema.org terms. So they're the basis for the POLDER best practices document, and they're the ones that actually give the nitty-gritty implementation guidance on how to do the markup. So how I like to describe it, you have schema.org as your base terminology. You have your Science on Schema, or your SOSO, as your subset, where they picked and choose what they liked for the earth science community. And then we have POLDER, one step kind of lower, where we're picking and choosing the best terms to implement in polar repositories that would enhance data discovery for polar data sets. And that all stems to our POLDER best practices. So we finally had our first version released in October. We are still migrating it over to our POLDER crew GitHub, but it highlights, I believe we have 12 mandatory terms and 6, my numbers might be slightly off, but 6 recommended terms for actually implementing the schema.org. So these are the terms that Melinda will be helping us with later today. And it kind of points more directly to the Science on Schema guidelines with the actual guidance for implementation. But our best practices guidance kind of gives the justification on why it's relevant to the polar community. So again, why federated search? It tries to solve our standardization problem, where instead of trying to make everybody conform to the same metadata standard, you just implement this lightweight markup, and then we can all be indexed and federated into this one user interface. So it is aligning with other projects such as Ocean Info Hub, I believe EarthCube, and there's one other that I'm also blanking on right now, but there's other domain initiatives that are doing similar things. So we wanted to tailor and kind of work alongside the community to make it useful for our polar community. So for the federated search and researchers, what does it mean? It enhances data discoverability as long as researchers choose to host their data sets and publish them within a repository that actually participates in the federated search and does the schema.org markup. And yeah, supposed to be one-stop shop, but a single user interface to search across various repositories and other aggregators such as DataOne and the CCADI consortium and whatnot. And it's a community-led project, so all of the development and work done is by the community and guided by community's needs and wants. So we officially launched in March 30th of last year. We're almost approaching a full year of production, and Melinda's been super busy. So we still have a Jamboard for feedback, but more or less we appreciate the Trello board use, which is where Melinda is able to have users kind of drop in comments or cards on what they would like to see developed or see added to the federated search, and then it's kind of added into like a task tracking list, and they can see the development if there's any done on their requests through the Trello board, and that's open to the public. I will make sure that the link is in the agenda after this as well for the future. So yeah, as of right now, we have 4 various search options. So you can use text search, temporal, spatial, author. And yeah, I believe, yeah, so we have the spatial search. Melinda's updated it where now if you find a point on the map from your term or author search or whatever you're looking for, you're able to click on it and it brings you right to the metadata record that you're interested in. And then once you select that metadata record, it pops up and you can see stuff like your keyword search, your abstract, your authors, any digital object identifiers, so your DOIs, and then it will bring you and point you back to the original repository source to actually access the data. So you're not accessing data through the federated search, it's more metadata discovery, and then brings you back to the actual data source. And this helps us with a lot of licensing and access restrictions and whatnot. So how Melinda has it set up is we have our federated search backend. It uses our Gleaner software and then indexes and pulls from the repositories that have completed this give-it-out markup, and again, spits out the results. We also index DataOne since they are an aggregator and they host various repositories as well. So their search results are also being aggregated into the federated search and displayed in the same space. Melinda is here, thankfully. So if there's any more technical questions, please feel free to point them in her way. And yeah, as of right now, we have, I believe it's 19 actual repositories indexed into the federated search. 4 of those, are aggregators, so our GCMDs, our DataOnes, our data sites, and CCADI. But in total, I think we're at about 19 repositories and hopefully more after today. And then, yeah, we have 3 current avenues to be included in the search. The first one is if you're already indexed by one of the aggregators, you are getting funneled into the federated search. So you're there, you're done, which is great. Option 2 is if you have indexed or implemented, the scienceonschema.org guidelines. Since we are using their recommendations to actually do the implementation, the terms and are the same, so you still will get indexed through the federated search. And then option 3 is today. If there's needed help to do the actual one-on-one implementation, we are here to help. And that's, yeah, so thank you all for coming today for that. I'm glad to be doing what we can to help everybody get indexed in. And then looking forward, some challenges that are still coming up is that we wanted to make sure that it's open source and portable, that there's clearly laid out documentation, it's cost effective, maintained, and relevant to community's needs and interests. So we only want to keep it going and everything as long as the community still sees relevance and need for it. So yeah, want to learn more? Workshop today. We will be having an advisory team meeting. Tentative date is March 7th. I still need to send out the connection info and everything for that. So that will be coming after today's workshop. And then, yeah, any other direct questions, Melinda and I are always happy to help, and please don't hesitate to reach out. And then these are all the links that will be added to the agenda, if they're not already there, to all the various RDA stuff, primers, federated search documentation and whatnot. And then just as good for good measure, these are the different semantic technologies that are used throughout the federated search, just kind of have it condensed into one slide. So that is it for our intro. And hopefully now we are ready to get down to the nitty-gritties. So I will drop the link to the POLDER best practices. And that is the, again, POLDER guidance on actual implementation. And then, sorry, I'll double check the chat. Yeah, sorry, I know the acronyms, I get caught up in acronyms, so thank you for explaining the so-so term, if I didn't already. And then data one, Julia, yes, so the Arctic Data Center content is in data one, so it is already being indexed into the federated search. So there is the best practices document for everybody to see. Does anybody have any questions, comments, concerns at this point, or are we good to hand it over to Melinda and get the ball rolling on what we came here for? Yeah. Awesome. Okay. If that changes, feel free to pop it in the chat or let me know, or Melinda. And yeah, so I believe, Melinda, you have some stuff that we were able to kind of have a precursor with. I believe it was, what was it, Norwegian Polar Institute? So Stein's?
Yeah, the Norwegian Polar Data Center has graciously offered to be an example today. And I also got an email shortly before this meeting from Ethan, who's on the call with the World Glacier Monitoring Service. So we've got 2 examples today, which is great. Yeah, so one point about data one is that we're querying them with a spatially bounded query. So it's a way of sort of ensuring that we're getting Arctic and Antarctic relevant data from them, just by saying, query data one, but only above and below these latitudes. So it's a very rough approximation. So if the ADC somehow has data at the equator, that will not show up in our queries. But aside from that, yes, you will get Arctic Data Center data through the POLDER federated search. So I'll just share my screen. So this is me sharing the workshop notes, basically. And it occurred to me, actually, because of the example that we're going to work through right now, it's probably useful to link to the crosswalking guides in here somewhere. And you'll see why in a moment. But we will be using 2 important documents as references here. So there's the scienceonschema.org dataset guide, which is all about the nuts and bolts of describing a data set using SOSO, what you should be doing and what isn't valid. And this is considered a definitive guide for the shape that the metadata needs to take for the POLDER federated search as well. And then the POLDER specific best practices, which are basically it takes the schema.org guide and says, okay, you really need these fields in particular, please have them. And it says, please implement them in the way that this says to do. So if, for example, SOSO changes their guidance on keywords, which they probably won't, but let's say they do, please use that. And the reason for that is that the federated search is using parsers that understand how to deal with schema.org and SOSO metadata. And those specifications sometimes change. And when you have a machine like a computer parser, it looks at the spec every time and says, this is how I figure out how to read things. And so when those change, the computer's idea of how to read things change. So that's why it's good to be using the ESIP reference for how exactly your data should be shaped. And the required and optional fields for POLDER are basically, well, please have temporal coverage. If you don't, and you do a date search, if someone does a date search and your data set does not have date information, then they won't find your data. Because if you're looking for data from, do we have a link to the other reference document too? Yes, it is.
I'm
here.
dropping it in.
Yeah, they're both here. And then thank you, Chantel. So we have a date search, like if you don't have a date on your data set and someone does a date search, they won't find it, because if they're looking for data sets from, I don't know, before the year 2000 or whatever, and there's no way of telling that, then yours just won't come up. And that's why that's important, basically. So let's get into it here. So we've got the Norwegian Polar Data Center as an example. And just to give you an idea of what their data catalog looks like, it looks like this. So they already have a cool search and they have lots of data in here. You can see I looked around on that subdomain for a sitemap, which I could not find. They do have a robots.txt though, and both of those things are important for a federated search because it needs to know where your data sets are in order to index them. And it needs to know where your robots.txt is in order to do it politely. Stein, you have a question, please.
No, I just wanted to say that I'm very happy that you've chosen to use this example today because it's useful for us, of course. We are privileged to have a glimpse of this website now because we're actually in the process of transitioning into an entirely new system, which will also entail a few modifications to the data model. So we're going to be listening very carefully today and hopefully be able to use this discussion as an input into the last stages of development of the new system.
Oh, that's fantastic. Thank you. Awesome.
Yeah, it is.
It's always nice to know that my work has real world impact in that way. So super cool. Could I zoom my browser just a little? Yeah. How's that? And I'll do it on the other tabs as well. Sorry, what?
I just wanted to say thank you.
Yeah, you're welcome. It does get a little hard to read in these screen shares, so I'll try to remember to do that when I open up a new tab. So this is a document on the web that tells web crawlers how to behave in a polite way. Sometimes they will have timeouts between requests, so your web server just doesn't get completely hammered with like thousands of requests per second from someone's web crawler. And Gleaner will listen to this, which is great. And sometimes these will actually tell you where a sitemap is or where parts of the web page are. So I always go looking for them. Since there's no sitemap for this domain, we have to get creative if we want to index it. But there's a nice API. If you wanted me to zoom my browser, boy, will you ever now, that will give you all of the data sets that they have there, which is pretty cool. And it'll even give you them in different formats. Maybe not. At least I thought this one did. But you can see, oh, okay, look at that. There's a list. It's paged, so you can go through it and consume all the metadata that you want. Pretty cool. So that would be a good way for the federated search to get that out. It's able to consume just big metadata APIs like that. And when it does that, it doesn't have to visit every web page, every dataset landing page. Embedding your metadata in your dataset landing page is a great way to go. But this is also a great way to go. And so if we look at a dataset landing page in here, you can see that it has a lot of rich metadata about the data set. We've got all sorts of things that we would need: description, we've got spatial coverage, we've got time spans, we've got authors and investigators, lots of keywords, and a whole section about machine readable data, which is pretty cool. There are lots of different metadata formats here. I see at least 2 that Data 1 can consume directly, actually, if you wanted to go that route, by the way. And quite a few that would crosswalk well to SOSO. So the dataset page, or the dataset landing page itself, doesn't seem to have embedded metadata, but it has these links. So we would know how to get the metadata of the data set out in a machine readable way, which is great. There's they have their own JSON metadata format here. So they're their own metadata schema that's custom made for their repository, which is a pretty cool thing to do, really. That means that your metadata will match your data and represent your data exactly. The disadvantage is that nobody else is using that metadata schema. And so in order to be compatible with things like ESIP SOSO or the POLDER best practices, you basically end up with a crosswalking exercise. This is a very rich schema. You can see that there is a lot of stuff here. There's ways of classifying topics, of licenses,